Hello, welcome to a quick way of learning and enjoying math courses from class 9 to class 12. We'll begin with class 9, mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee. I am an ex-senior professor of Science and Nuclear Physics, Kolkata, and an adjunct professor at Homi Bhabha National Institute, Department of Atomic Energy, Mumbai. This is my email address, and my research interest is given in Google Scholar Citation. Just type Sangam Banerjee in Google Scholar Citation and you will get my research interest in detail. I will use my handwritten notes and not any sophisticated tools. Here content is important rather than decoration and show. I will try to cover full mathematics course from class 9 to class 12. Each lecture will be around 30 minutes of 10 to 15 classes. Almost all proofs and examples will be covered for each classes. These lectures can be considered as free tuition or maths for beginners. My advice will be discussed with friends, seniors and teachers. If you like these lectures, then please advise your friends to listen. Write notes only after listening the lectures. You can pause in between. Go back to your NCERT textbook chapters to fill any gap in understanding. So let us start. Lecture 1 for class 9. We start with geometry, line, angle and circle and triangle. And as you know, geometry is very important for mathematics. It was written in entrance by Plato, a Greek philosopher. Let no one ignorant to geometry enter. Okay, so this was the thing. So let us start. In the first lecture, I will define what line, angle, circle and triangles are. Okay, this is the introductory. So what is a straight line? Straight line is nothing but the shortest distance from A to B. This is the shortest distance. If there is a curve, then it is not shortest. The length of the curve line is more than the straight line. So point A moves to point B in a shortest distance traces a straight line. And if continued from point B along the same direction to point C, then I can write that line AC is equal to line AB plus BC. Okay, in short, you just write AC is equal to AB plus BC. These are the notations. So some notations when you write AC means a line from point A to point C. And sometime if you call it a ray, suppose this is a dot and this is a ray arrow, then I write on top ray. This we will not deal here. It will be used in a higher classes. Now what is an angle? How do you define an angle? If a point B moves towards point C prime, see, instead of moving straight, it moves towards, say, up or down of the straight line C prime, where point C is not along the straight path of AB, then the line BC prime deviates by a prescribed angle theta. This is the angle theta. Okay, deviates from there with respect to the straight path. That is when C moves to C prime. Okay, this is. So I write this theta degree as angle. This slanted capital L is denoted as angle. So when I write like this angle, then it is C prime BC is an angle. What is the angle suspended? Is theta degree. Okay, and the angle can be anywhere. This line can go backward, it can go upward, forward, or it can go downward or downward in a backward direction. So then you have to, the angles are denoted. Here I am denoting as theta degree. What is a circle? These are all definition I am giving. When one of the end point of a line AB, say A is fixed and this one of the end points, say B, okay, other end point. One end point is kept fixed, say point A, and say point B moves around a fixed point A, keeping the distance same, constant. Okay, then we say the point B traces a circular path, and this line traced is called a circle. Okay, if I fix this A and B, I move it like this circle in a circular way, I call it the line traced by that point B is called a circle. Here I define here. So this is a circle. This is a radius, say from point A to point B. I am calling it as R, capital R. This is the radius of a circle, and this point is moving like this and traces a circular path. and any point from this circle to the other side of the circle, the line passing through center, is called the diameter. Diameter will always pass through the center. If it is not passing through center, then it is a chord, and we'll come what chord is also. Okay. So length AB is called the radius. This length AB is called the radius, and distance from center point A to any point on the circle is called the radius. From this to this point, from center point to this circle, or any point in the circle, the distance from center to any point in the circle is called the radius. And distance from any point of a circle, here distance from any point from the circle to a point passing through the center of that circle in a straight line is the diameter of the circle. Okay, so diameter of the circle will always be equal to twice the radius. Okay, this is the radius and this is the radius. So this d is equal to 2r. Okay, when point B moves a complete circle and come back to its original position, it covers 360-degree angle around the center. That is point A. Okay, so it covers from here to here, it covers a 360-degree. Okay, why 360-degree? There is some historical reason from ancient Greek and even Indian astronomer. The circle was denoted by 360-degree because one of the reason it was attributed to Earth's orbit around the sun in about 365 days. Okay, this is a solar calendar, and in India we used to practice, I think, lunar calendar. So lunar phase cycle is 29.5 days from one new moon to another new moon into 12 months is approximately 354 days. So somewhere you can approximate between these two as 360 days. I will not go into detail why 360 has lot of advantage in ancient times. So they were using 360. I will not go into detail because they were using for navigation purpose and for astronomical and for recording things, and each degree angle they had divided into 60 arc minute. When you navigate, you have to be very precise, otherwise if slight difference you will go somewhere else. Okay, when you are in sea. So, and 1 arc minute is also divided into arc second. So I will discuss this in a higher class maybe, or maybe in the end of our this course, 9th standard. Let us first complete the 9th standard which are given in the textbook. Okay, I will not go into detail of this. So these 2 pages I will quit. So now the circle can be divided into 4 parts or 4 pieces. Each pieces are called the quadrant. This is first quadrant, this second, third, fourth. And if you divide in equal part, definitely 360 divided by 4 is 90 degree. So any line which crosses each other and the angle subtends 90 degree are called perpendicular. And I can write this angle as BOA or AOB is the same thing. So that you have to keep track. Okay. So now, as I said, any line, this is one line and this is one line, crosses each other, and this is 90 degree. So this is perpendicular. This line is perpendicular to this. And any line, this is 90, then this is 90. Okay. Because this is half of the circle. So 90 plus 90 is 180. So any 2 linear pair, these are called linear pair, here and here linear pair of angle, this 90 plus this 90 is 180. So I can write here is 180. So you take a stick and you try it out, this one, that if you cross 2 straight line, the angle subtended say is theta. So the opposite angle here, the opposite angle here also will be theta degree. And if this is theta degree, I know the straight line is 180 degree. So 180 minus theta will be this angle. So sum of this angle theta degree plus 180 minus theta plus theta cancel is 180 degree. So similarly this line also will be 180. Okay. And if this is 180 minus theta, then opposite angle this also will be 180 degree minus theta. Same it will be. So if there are two parallel lines, okay, these two parallel lines, this is theta, as I have written here theta. So this also will be theta because it's two parallel line. Okay. So when this angle, both the angles are same, then these lines will be parallel, or if two lines are parallel, then these angles will be same, vice versa. Okay. So this is what we have explained here. Now we will define what a triangle is. This is a triangle. This is an acute angle triangle. We'll come back to all this in later lectures. You can draw, this is obtuse. This is more than 90 degrees called obtuse, and these are less than 90 degrees is called acute. All the angles are less than 90 degrees. This is an acute angle. So what is there is one unique property that sum of all the interior angle of a triangle is 180 degree. So how do you prove that? It's very simple to prove. So if I draw a parallel line here and parallel line here, I just extend this line along the base. Then I know, see, these two are parallel. Okay. So if I cut a line here, this is parallel. So this angle subtended will be equal to this angle, and this angle, I said opposite angles are same. So this, so angle 4 is equal to angle 3 because this angle is same as this. So angle 4 is equal to angle 3. Similarly, I cut this here. Okay, this is the internal angle here. Okay, this angle I call it 5. So this angle and this angle in this is same, and this angle has to be same. So I write angle 5 is equal to angle 1, angle 4 is equal to angle 3. Okay, so now I write angle 5 plus 2 plus angle 4 is 180. I know this is a straight line, so this has to be 180 degree. And also I know that angle 5 is angle 1. Here I have written, I substitute it, and angle 4 is equal to angle 3. So angle 1 plus angle 2 plus angle 3 is equal to 180 degree. I may be going pretty fast, but you can always pause, go back, think about it and do it. Similarly for here also, you just think about it. I have labeled it so you can understand. Okay. So for triangle, sum of all the three interior angles is 180. Angle 1 plus angle 2 plus angle 3. So triangles are object which has three sides and three angles, and these are also polygon. There can be 4 sides called square, rectangle, or can have 5 sides, pentagon. We'll come to it in later lectures. Okay. Now we'll come to axioms and theorems. Okay. What are axioms and what are theorem we'll define here. So axioms, word axiom comes from a Greek word meaning worthy. Axiom is accepted as a true because it is self-evident, it is obvious. So then this becomes, you don't have to prove axiom. So you take it for granted. The principle that is accepted as true without proof are axioms. So you take it for granted. Okay. Now I am dealing with chapter 6 and I am going to write same, here when I say 6.1, that is axiom number 1 at chapter 6 or 6.1. Okay. So what it says, axioms. This will be easy for you to go back to your textbook. That's why I am writing these numbers also. Okay. So if a ray stands on a line, then the sum of two adjacent angles so formed is 180. We showed that if this ray stands on a line, then this angle plus this angle is always 180 degree. Okay. Like I can say angle COB plus angle COA plus, okay, is 180 degree. Angle COB plus angle COA is 180 degree. Okay. Or I can say angle AOB is 180 straight. Okay. Axiom 6.2, if sum of two adjacent angle is 180 degree, then of course if the sum of two angle is 180 means this has to be straight line. Okay. Then the non-common arm of the angle forms a line, straight line. Okay. Axiom 6.3, if a transversal intersect two parallel lines, this is called the transversal line, it crosses, okay, parallel line, then each pair of corresponding angles are equal. So as I showed earlier, this angle and this angle will be same. Okay, this angle and this angle will be same. This angle will be same as this because opposite angle. This angle will be same as A. This is A, angle A also. This is also same angle. Okay, and so here I have shown that angle A is equal to angle E because it is crossing. So this will subtend the same angle because they are parallel. So angle which will subtend here will also subtend the same thing because they are parallel. Okay. So all of them, angle C will be angle G, angle F will be angle B. Okay. Angle H will be angle D. So they will be because they are parallel. Okay. So if two corresponding angles are same, then the line are parallel. Okay, if the lines are parallel, corresponding angle has to be same. So vice versa. Okay, so same thing in other words, if a transversal intersects two lines such that a pair of corresponding angle is equal, then two lines are parallel to each other. Okay, as I said earlier. Okay, so now theorems. What are theorems? Theorem is a statement that has to be proved or can be proved by using axioms or by earlier proof. Okay. So theorems you have to prove it, okay, by axioms. So you can use axioms and prove it, okay. The proof of a theorem is a logical consequence of axioms or previously proved theorem. Is it clear? So theorem 6.1, again same thing I have taken from chapter 6, theorem 6.1. If two lines intersect each other, then the vertical opposite angles are equal. Okay, this is a theorem which I have explained. Okay, if two lines intersects each other, then this angle will be equal to this angle and this angle will be equal to this angle. Now you will say, okay, you prove it. Okay, you can prove it. We have to prove that this theta 1 equal to theta 3, theta 4 equal to theta 2. So I use a trick. I know that theta 1 plus theta 2 is 180 and theta 2 plus theta 3 is also 180. So which is common? Theta 2 is common. Okay, so if theta 1 plus theta 2 is equal to theta 2 plus theta 3, I can cancel both from the both side theta 2 and I will get theta 1 is equal to theta 3. Here I have done the same thing. Angle theta 1 plus angle theta 2 is 180, angle theta 1. Angle theta 2 plus angle theta 3 is again 180. So I have cancelled angle theta plus theta 2. Okay, just go take a snapshot, pause and go through these steps. Okay, these are very simple. Otherwise, time will unnecessarily go. Okay, if I may be going pretty fast, but you can always go back and forth and see the arguments in the steps. If a transversal intersect two parallel lines, then each pair of alternate interior angles are equal. What are the alternate interior angle? This is one angle. Okay, and this is one angle. This was corresponding angle. So alternate interior angle, this is one angle between this parallel line and transversal, and this is between parallel and transversal. Okay, this is alternate. So this will be equal to this, this will be equal to this. Why this will be equal to this? Obvious, because this is equal to this, we have proved it. So if this is equal to this dotted line, then opposite angle has to be equal. So if A equal to B, B equal to C, then A equal to C, something like that. Okay. So this is a proof here given. We have to prove that angle BQR, this angle BQR, and QRC, and this angle QRC equal. So now we use axioms. Okay, traversal from axiom, that is when traversal intersect two parallel lines, then each pair of corresponding angle is equal, which we have proved it. Okay, corresponding angle axiom you write is, so angle BQR is equal to DRS. And from theorem 6.1 earlier theorem, when two lines intersect each other, then the vertical opposite, this is vertical opposite, corresponding angle is equal, vertical angles are equal, so this is equal to this. Okay, so just go through the step, pause it, see what I have written. So I have written here what I have said. So it implies angle BQR is equal to angle QRC. Okay, I always say quite easily done, but there is some Latin long form of this one. You can see it in Wikipedia. So now we also know that alternate interior angles are equal if traversal intersect two parallel. If traverse interior. Two parallel line, alternate interior angle. So if the alternate interior angles are there, intersects two lines, then they have to be parallel, vice versa. So from here is the same thing. Here 6.3 says the same thing. If a traverse intersects two lines such that a pair of alternate interior angles are equal, then the two lines are parallel. Okay. If they are equal, then this line has to be parallel to each other. Similarly, this theorem 6.4, if a traverser intersect two parallel lines, then each pair of interior angles on the same side of the traverser is supplementary. What do you mean by supplementary? Same side, okay, of the traverser. Say here I have done, this is other side, but same side means this side and this side. So if I have this side and this side, it is said it has to be 180 degree. This is a supplementary. So how do I prove this in theorem? You see here, this is the line. So angle 1 plus angle 2 has to be 180. So let us don't see the proof. Let us see from here what happens. This angle 2 will be this angle. This angle is what, 180 degree. Okay. Now this angle, you bring it here, because now you know this is 180 minus 1, you bring it here. So 180 minus 1 plus 1, so it is 180 degree. Is it clear? Repeat, go pause, listen to me carefully. Okay. So if I say angle 1 plus angle 2, if they are this angle equal to 180, then they are called supplementary angle. Okay. From the above you can also prove this. And theorem 6.6, lines which are parallel to the same line are parallel to each other. If this line is parallel to 1, 2 is parallel to 1 and 3 is parallel to 1, then 2 is parallel to 3 also. So I have written here, is obvious, because if this is parallel to this is parallel to this, then all of them are parallel to each other. 1 is parallel to 3, 1 is parallel to 2, 1 is parallel to 2 and 3. Okay, now theorem 6.7, the sum of interior angles of a triangle is 180. We have proved it earlier. Okay. Theorem 6.8 says if a side of a triangle is produced, okay, I have taken word from your textbook, it is extended actually. If it is extended, one of the side is extended, then the exterior angle so formed is equal to the sum of two interior opposite angles. What is saying that if I extend one of the triangle, one of the side, then you have an exterior angle. This is called the exterior angle. 4 is the exterior angle. Is nothing but angle 4 is equal to angle 2 plus angle 3. Sum of the angle. How do you prove it? It's very simple. To prove angle, we have to prove this theorem. Okay. We know from theorem 6 that sum of all the interior angle of a triangle, angle 1 plus 2 plus angle 3 is 180 degree. And angle 1 plus angle 4 this is a straight line. This is also 180 degree. So now 180 and 180 is common. I can equate them. L1 plus L4 is equal to L1 plus L2 plus L3. So I cancel both L1. So L4 is equal to L2 plus L3. Go through it. You can always pause. Okay. And go through it. Now let us go to an example. This is example 1. In figure 6.31, this is from your textbook. If PQ is parallel to ST, and angle PQR is given 180 degree, and angle this one RST is given as 130 degree, then find what is this angle. So it is very easy now. I draw parallel line. Okay, parallel line to ST and parallel line to PQ. So now these two are parallel. Then I have drawn like this line. So if this is 110, so this has to be 70. 110 plus 70 is 180. Similarly, 130 plus 50 is 180. Okay. So now I know this is 50. This is 70. So 50 plus 70 plus x should give me 180. So x is 180 minus 70 minus 50. So x is equal to 60 degree. Go through it. You can always pause, see, and then you can write notes. First listen to the lecture and then only you write notes. Example 6.3.2. This is, you are given a triangle with an angle here 62 degree and this angle y, angle x is 62 and total angle y is 54, and it is saying that there is a center point O. This line, you bisect this angle and you draw a line bisecting this angle. I will show you how to bisect during construction time. It is very easy to bisect an angle also. So you bisect this angle here and it will meet a point, and that point is called O. So it is asking that what is the angle O. So I know that this, if this is 54, so half of this is 27. Okay. So, or also I know that 62 plus 54 plus angle Z is 180. So this angle will be, so angle Z will be 180 minus 62 minus 54 is 64. So this angle will be half of, this is 32, this is 27. This is another triangle here. So this angle plus this angle plus this angle has to be 180. So I can write that angle O plus angle 27 degree plus 32 degree, okay, is 180. So I bring these two number in the right hand side. So angle O, okay, sorry, this has to be O. Angle O is this, is equal to 121 degree. So angle O is 121 degree. Okay, now we will summarize what we have done so far. What we have studied so far: vertical angles. What are vertical angles? That angle, if two line crosses, angle A is equal to angle B, angle C is equal to. When I write 1 dash, that means same 1 dash means they are equal. 2 dash means they are same. This one and this one is same. It's a labeling. You just label it by 2. So that means this and this is same. So this I will be using when I am going for other higher geometrical objects. Okay. So this we have studied. Here, of course, it is perpendicular. You will have opposite. All are equal. Linear pair, we have studied that if you have a straight line and there is one arm going suspended in angle, it will give you angle 1 plus angle 2 will always be a 180 degree, and these are also called supplementary angle. Okay. So what are the congruent angle? Congruent means same. So when I am going to triangle, we will use congruent, similarity. We will see. That's why I am introducing this term, words, congruent. So this is same, 1 dash here. Okay, 1 dash. So angle 1 and 2 is same. If you draw here, same line, no, it is, this all line is same, parallel it is. So whatever the angle it will make here, it will also make the same angle. It's obvious. And whatever angle it will make here, this will also make the same. So these are called the corresponding angles. These are called the alternate exterior angles. These are exterior angles. Okay. Then alternate interior angles, they are inside. Okay. This angle and this angle also will be same. Okay. So these are the congruent angle. Okay. Because this is 2, this angle will be same here, opposite angle same. So 1 is equal to 2. Okay. Supplementary angle, angle 1 plus angle 2 angle has total has to be 180. This angle will be supplementary, okay, which we have proved, and we have also seen that this is also supplementary angle, this angle and this angle, okay, because this 1 will come here. So 1 plus 2 is 180 degree. Angle 1 plus angle 2 is 1. So similarly, if I draw, you have how many linear pair of angles? You can go through it. You will have 8 linear pairs on there. 1 plus 3 is 180. 1 plus 2 is 180. 2 plus 4 is 180. 3 plus 4 is, here is 4. 5 plus 6 is 180. 6 plus 8 is 180. 8 plus 7 is 180. Okay. So that way you will have 8 linear pair of angles. We have also shown that sum of all the interior angle of a triangle is 180 degree. And if you extend one of the triangle side, then the exterior angle is sum of two opposite angle. Okay. If this is there in this point, this angle, then opposite angles are 2 and 3. So angle 4 is always angle 2 plus angle 3. Okay. This is the first lecture I have finished. Thank you and see you in the next lecture.